Yes.
Okay, so there's 50 multiple choice questions, 24 from your midterm. So go from those are multiple choice questions, not calculations. Then you need to be able to read a chemical equation and give me the mole ratio similar to the fill in the blank that you had on that quiz. I think it was for chapter 9. You need to be able to define what a molar mass is. You need to know the value and the definition of the ideal gas constant. You need to know STP, what is the value of the temperature in both Celsius and Kelvin, and you need to know the pressure, okay, typically in atmosphere or millimeters of mercury. You need to know the 5 properties of a gas. It's one of the PowerPoints. You need to know those pressure conversions that I asked you to memorize, 14.9 psi, 1 atmosphere, 760 millimeters of mercury. Those, okay, it is 7, thank you. You need to know the relationship between pressure, volume, temperature, and moles, similar to the ones that you had on your quiz, where you had to say, if I change the volume, what happens to the pressure? If I change the number of moles, what happens to the pressure? And you had it also on your post-lab for experiment 16. So that's what I mean by relationship between pressure, volume, temperature. You need to know what anhydrous and hydrate are. We talked about that last time, I think in chapter 13. Okay, what is an anhydrate? It has no water attached. A hydrate has the water attached. You need to be able to define a covalent bond. You need to be able to recognize, if I give you A, B, C, D, which of the following is a ionic or covalent bond. I don't remember which is which on here. So a ionic is going to be a metal and a non-metal. Covalent is going to be 2 non-metals. Okay, so you need to be able to look and identify which ones would be either ionic or covalent by the elements that are involved. And you need to be able to define what a covalent bond is. It's the sharing of electrons. We talked about 3 intermolecular forces: London dispersion, dipole, and hydrogen bonding. You need to know which one is the strongest, which is hydrogen bonding, which is the weakest, London dispersion. Okay, you need to know the physical properties that are affected. You need to know that vapor pressure is decreased, that boiling point, viscosity, and surface tension is increased. With the greater the intermolecular forces, the lower the vapor pressure, the higher the boiling point, surface area, and viscosity. So you need to know those physical properties and how they are. Do they go up or down with increased intermolecular forces? You need to know the electronegativity trend, okay? That it increases as you go up a column, it increases as I go across the column, with fluorine being the most electronegative, francium being the least electronegative, okay? We talked about define a solution. So a solution is a homogeneous mixture of a solute dissolved inside of a solvent. So you need to know what the solute is. It is typically the solid that is dissolved inside of the liquid, which is the solvent. We also talked about solubility, and that's the amount of substance that will dissolve in so many milliliters. We talked about like dissolves like. So if I give you a polar substance and I ask you which of the following will dissolve in it, you're looking for oxygen. Okay, so polar typically has an oxygen in it, and so like dissolves like. We're going into acid and bases today, so you need to be able to know the properties of an acid and base. You need to know what a buffer is, and I'm going to point these out as we go through the chapter today. You need to be able to define dissociation and ionization. You need to know the pH scale. Below 7 is an acid, 7 is neutral, greater than 7 is a base. You need to know how to calculate the pH, and I will give you that formula, which is the pH is equal to the negative log of the concentration of H+. I'll write it on the board as we go over it. We're also going into chapter 18 on radiation today, so you need to be able to define and give me the properties of alpha, beta, and gamma radiation. I'm going to give them to you. I'm going to give you a slide, and I'm going to say memorize it, okay? You need to know the uses of radionucleotides. What do we use them for? We use them in medical nuclear medicine, but I'm going to give you some specific ones like I want you to know. And then we're going into calculations, okay? Now we're going into calculations. There are 11 calculations. for a total of 56 points. So half this test is calculations, okay? But your total points are 106. Your grade's going to be out of 100, so that's like 6 bonus points that are written into the exam, okay? So you can, you know, at least blow 1 or 2 calculations here. Okay, so there are going to be 3 gas law calculations similar to the ones that were on that quiz that you will get back in just a minute when I get the 2 quizzes back from the ladies who are taking them. You need to be able to calculate the polarity of a bond. There is a sample on the quiz that I just gave you. I'm going to give you the electronegativity value of 2 different elements, and you need to subtract them. Okay, where's it at? Question number 4 on quiz 9, chapters 11, 12, and 13. Says given the electronegativity of oxygen is 3.5 and the electronegativity of carbon is 2.5, is the bond between oxygen and carbon polar or non-polar? So to do that, you need to know 2 things. You need to know that you have to subtract those electronegativity values. You get the absolute value. So the absolute value is 1. We know that if the difference is 0.5 or greater, it's going to be polar covalent. If it's 2 or greater, it's going to be ionic. If it's less than 0.5, it's nonpolar. So I wrote that on the board last time. We're going to do a mass percent calculation. So it's going to be similar to the one that is also on that quiz that I just showed you. There's a mass percent there, and it is also from experiment 19. Okay, so it is just like the calculations you had to do for experiment 19. You're going to have to calculate molarity, just like the quiz 9 that I just gave you, and also experiment 19. You're going to have a mass stoichiometry problem. So you're only going to have 1 stoichiometry problem. It's going to be mass. So you've got the 3x5 card, so set it up. What I'm given, molar mass of what I'm given on the bottom, mole ratio on the second one, molar mass on top of what I'm asked for, so that you know exactly how to do it, okay, and where you're going to put things. Okay, you've got a 3x5 card. Use it wisely, okay? So if you're having problems with those stoichiometry problems, write it out. And of course, all of these calculations that I've told you, make sure that you have those formulas on your card so that you don't blow it, okay? There's going to be 2 calculations from the midterm, so they're going to be word for word from the midterm. Okay, so practice those calculations and make sure you know how to set them up. There's also going to be, from today's lecture, you're going to have to be able to balance a nuclear reaction. You're going to have to give me the product of a nuclear reaction. It is a lot easier than it sounds. And you're going to have to calculate radioactive decay, and that is easier than it sounds as well. So those 2 things are new that you have not seen, balanced nuclear reaction and radioactive decay. It's just that I think it's worth more than 1 point, so I make it a calculation instead of a multiple choice. Okay? Any questions about what I said?
That was only 9 times.